Hi, a very good afternoon to all the students. Hi, everyone. I can see many of you have already joined. Just now, the first one should be Sherwin, right? Hong Sherwin is the first one who joined. So good afternoon to all of you. I believe all of you are now busy in preparing your assignment, everything. So for today, since we already finished our tutorial questions, do you have any question you want to ask me about the tutorial or any other matters before we start to do some revision on the past year paper? For your information, this question has been done by other group. So we also have to do exactly the same so that both groups will have the same revision. So any one of you have any question? So I can see many of you have already here. So let me see who is here. We have Chie, Chong Yi, Han Xiang, Han Dong. You all already present your assignment, right? And then we have Juimin, Kashing, Leong Ho, Mei Lin, Wang Liang, Xuewen, Yan Shang. Yan Shang haven't presented yet, and Yi Hang Hua. So good afternoon to all of you. So today we are will be doing our past year paper. This will be the paper that we will do the revision. This is the paper. So please jot down this date, 24 April 2019. When you do your review past year paper, actually you can search your paper through the online website from our TAUC library. TAUC library. So this is the this is the place where you can get your paper. So you come to here, and then you go to the TAUC Institutional Repository IR. Then we search our code PTEE 3213. Then we enter. I'm not sure why it's not secure, but I think it should be secure. So we just go in. Then you search the paper. So one of them will be, for example, this one, April. Yeah, this one will be the paper. So just click and then go in and then download it. So since I have already discussed it before, so I already downloaded it. Actually, it's at this place. So this is a 2.5 hours paper. Yeah. So let us go to the first paper. We have already done a lot of revision when we had our midterm. So today we are mostly going to do the other question as well, which is we will focus on question 1 today. Question 1 and also question, which question? Question 4. We'll do question 1 and question 4 because we haven't done this kind of question before. At least we try out once. So then we will be able to understand what is the what are the standards of the final exams. So now, without further ado, today I will mainly let you to do your own revision. So I will create a Jamboard for you. Yeah. So I will create a Jamboard. You can get your Jamboard over here. Start a new Jamboard. I will be glad if you will be able to write your answers in this Jamboard because I will be pasting all the questions over there. Let me do cut and paste. The first question is, explain why modern processors have multiple level of caches instead of monolithic cache. First, please try to answer this question. Any question, any answer you can think of? Why do we need to have multi-level of caches? You have already presented a lot of other processors, and you can see that all of them actually using multi-level of caches, right? Except for those earlier processors in 1980 something. After that, we all have a lot of levels of caches. So now let's try to answer using a Jamboard. before we move on? Or you can answer at the chat box. Yeah. You want, you can answer at the chat box. Explain why modern processors have multiple levels of caches instead of one big monolithic cache. Okay. So this is a bit theory. So I would like to let me give you some hint. Because if not, then you'll be wasting a lot of time over here. So let me give you the answer. Yeah. So internal, I'm so big. Okay, the first reason is internal caches have very short wires and are therefore fast. But smaller. Okay, so this will be the first reason. We have internal cache. We are very happy to have internal cache because it's very fast. But the problem is because it's very near to the processor, so the space is very limited. It has to be inside the processor most of the time. So it will be very small. So we resort to use the external caches. Caches are slower, but larger. We have the benefit of having a larger cache, but this cache will be slower because the location of it will be outside of the processor. So the wire connection will be longer because the speed of electricity is almost the same. So if it's longer wire, it will take longer time. So inside the processor, it will be faster. So this will be the two answers that you can actually look at. Yeah. So any question you have about these two answers? Yeah, let's take a look at these answers for 1-2 minutes before we move to the other questions. Okay, now we move on to do the storage revision. Later we'll do virtual memory as well. You see what kind of standards is for your finance. Okay, next one. We will go to the second page. Second question here. I believe you all have already done a little bit and a question on this. Let's try to do this. Okay. Consider a memory system such that uses a 32-bit address to address the byte level. So we now know it's actually a byte level. Yeah, it's at the byte level, and then 32-bit. What does it mean? That we have 32-bit, meaning that our address format will be 32-bit, right? Yeah, 32-bit. Just remember this first, 32-bit, because the addressing format will be having 3 parts for the cache. Yeah, so 1 part and 1 part here. Yeah, so what does it mean? Plus a cache that uses a 64-byte line size. Okay, now we know that inside a cache we have a tag, we have a set, and we have a offset. This is for the direct map only. For the direct map only. Cache with a tag field in the address of 20 bits. Tag field with the address of 20 bits. Okay, now, let us see what is the meaning of this. If we have the address of 20 bits, means here we have 20 bits. Yeah. So direct map cache. How do we know How do we know it's like this, the format? So I have to go back to the lecture notes here. So we now go to the lecture notes. Yeah, direct map. We have direct map, set, associative, and etc. You still remember? Yeah. Hope you still remember. Yeah. We have three types of cache, right? We have the fully associative, and then we have the direct map. So direct map, we have first bit here is a tag. First column is a tag. Then we have a bit. Then after that, we have the bit. This one is actually the R, the row in the cache, and then the last one will be the offset. Yeah, let us copy and paste over there so that you know where to get your answer, where to get the format. So this is the format: tag, set, and also the offset. Now, this is from lecture notes. Then we continue your rate. Show the address format. Where is the address format? This will be the address format. Yeah, this is the address format. And determine the following parameters: number of addressable units, number of blocks in the memory, and number of lines in cache, and size of tag. So how do we do this? So when we talk about 64-byte line size, 64 bytes, what is this? So we have the 64 bytes line size, means that one line has 64 bytes. So 64 equals to 2 to the power of 6. So you have a 6-bit. Okay, one line has 64 bytes, so you need a 6-bit to represent it. So we put it over here. Yeah, then 32 minus 20-bit minus 6-bit, you get another 6-bit. In this case, you will be able to find the address format. So we have done the first one. Yeah. And then the number of blocks in the mean memory. What is the number of blocks in the mean memory? Number of blocks is equals to 2 to the power of, this one equals to 2 to the power of 26. Yeah. So it will be equal to 64 mega blocks. Why? Because one block actually have 64 bytes. So that's why we have to take all these 26 bits for the main memory. But number of lines in the cache is 2 to the power of 6. Yeah, which is 64. 64 lines in the cache only. But we have 64 mega blocks in the memory. And then size of the tag is already given to you, right? Size of the tag is 20, right? Inside here. Size of the tag is 20, yeah? Already given. So this will be the answer. So any question, you can let me know. I will let you to see for like 3 minutes. If you don't understand, you can turn on your mic and ask me, or you can type your question at the chat box. Yeah. So let's study on this. Okay, if there's no question, then assume that you all can do it. So you can actually refer to this answer if you want to do revision again. So last one, we are going to do this one also with a direct map. Let's copy this one first. Let's see how to answer this question. I will paste over here. Same thing, but now I want you to try to do it. Consider a machine also with a byte addressable. Byte addressable, and then it's 16 bits. 16 bit, and also block size is 8 bytes, meaning the line size is 8 bytes. So assume a direct map consists of 32 lines. Cache consists of 32 lines. Then the box size is 8 bytes. So now you have to find out what is the address format. For a direct map, there are three parts. The first part will be a tag over here. And then we have a set. And then the last one will be offset. Now I want you to calculate the bit over here. What is the bit over here? So I will leave you to do. Yeah. Total is 16 bit, right? You can actually, I leave it to you to do. Now, I give you 5 minutes. Anyone can actually use your pen. After that, you write your answer there. How many bits? Then we map to all these things. Yeah. 5 minutes, yeah. Please do if you can. Don't be shy. Yeah. Please do this. Anyone can do? Xie, are you able to do it? Or Chongyi? I try. You try. Yeah. Okay. Thank you, Xie. Try to put all the how many bit there. Yeah. Thank you. Okay. Yes. It sounds good. Okay. Very good. Okay, very good. Let's get a bit positive. Here, can you please write the number over there inside the tag, set, and offset? Okay, very good. All these are correct. Eh? Yeah, very good. Yeah, let's see a bit of positive here. Okay, very good. Now you have the 3 bits over here. So we put the 3 bits. 3 bits over here. And then here we have 5 bits. And then here we have 8 bits, right? Now, the first question, into what line would bytes with each of the following address be stored? Into what line? Meaning what line means which line inside the cache, which line inside the cache that you will store. So you have to put the address into inside lah. Okay. So let's split it. 853. So we have to split it. This color not so contrast. So one, sorry, here, and then here we have 1, 2, 3, 4, 5. So block here. Yeah. Block here. And then block here. So for this one, basically the line is 3. How about this one? What's the line here? Line is, yeah, okay, very good. Yeah, who is this? I know who is this. Let me check. Who is this? Not sure. Heng Dong, is it? Yeah, okay, Heng Dong or Xie Ye. Let's just see a yellow picture. I don't see. Okay, very good. Okay, next one. What is this? Let's write it. Don't worry. What is this? Which line in the cache for direct mapping? Yeah, okay, 3 and yeah, should be Xie Ye, right? Okay, very good. 3 and 21. 21 is 1 plus 4 plus 8. 1 plus 4 plus 8. 21. 6. Oh, sorry. 16 plus 4 plus 1. Yeah, correct. Very good. 621. Okay, very good. Correct. Good, very good. So give a star, yeah, to Xie Ye. Okay. Now, suppose the byte with address of this is stored in the cache. What are the address of the other bytes stored along with it? So, what are the other bytes stored along with it? So cut, because it's 3 bit only, right? So write all the address there. So you just write all the same. In front will be the same. So here, we have the 0, 1, 0, right? So put all the other number 0, 0, 0, 0, 0, 1. Yeah. And then you continue. Finish up all this. Another 5. Yeah. Anyone can help to do? What are the addresses of other bytes stored along with it? So 0, 0, 0, 0, 0, 1. Yeah. 1, 1. And others. Yeah, thank you, Xie Ye. Okay, very good. All these are correct. Yeah, thank you. Okay, very good. So you all can do this. First question, within half an hour. Also inside exam, you also required to do so about the same time, slightly more than half an hour. But it's fine. If you can do it within half an hour, then it's fine. So now, next one. We are going to do the question number 4. If you have no question about this, may I know if anyone has any question about this question? Yeah. So thank you, Xie Ye, for doing this. Next question will be, because we already done the MSTAR law revision. So also instruction level, we already done once during our midterm. So now we go to the last question, which is the virtual memory. About virtual memory, also some cache. So now let's copy. Same thing I always copy. Explain the advantages of virtual memory. Yeah, let's go there. And then we try to do together. What is the advantages of virtual memory? Let's write your answer here. Maybe you can type over here. Yeah, type your answer over here. What is the advantages of virtual memory in 3 minutes? Yeah, anyone can do. Let's type your answer over here. Yeah, can you please write an answer over there? Chia again. Yeah, correct. Allow safe sharing of memory among programs. So very good. Correct. Still have two. Yeah, we still have two. That you allow safe sharing of memory. Second one, because your memory is slow. Sorry, your memory is small and size limit. Size is limited. Thus, you want to remove the burden. Okay, very good. Yeah, correct. Yeah, you're right. So these are the three answers. First is to allow the safe sharing of memory among the programs, and then remove the burden of a small and size-limited mean memory. The third one will be allow the non-contiguous memory blocks to be addressed as the box contiguous. Yeah, so these are the three advantages of virtual memory. Yeah, very good. Let's give a big round of applause to Chia. Okay, very good. Now, next to the next one. Today we only do this one only. B. Let's copy and paste that. We do together. This one is also a cache, but I think it's not direct map, if I remember correctly. Let's study how to do it. The address format might be different a bit. So we have a byte addressable, same thing. It's a toy computer. That has a physical address space of 512. Okay, so this is the in memory. In memory is 512 only. It's a very small one. Very, very small. Now, the computer use a simple one-level virtual memory system. So meaning it connect to one virtual memory in your hard disk and one main memory. There's no cache usually because it's very small. Yeah. So the page table is always in physical memory. So this one we don't care. It's already inside separately. So the page size is specified as 8 bytes. Now we have this is a virtual memory, not the cache. And virtual address space is 2 kilobyte. So the page size is 8 bytes and the virtual address space is 2 KB. So now you calculate the number of bits of each virtual address, which is the virtual page number. So now you have, what is this? You want to find number of bit each virtual address, which is the virtual page number. So what is the size of your virtual memory? The size of virtual address space. Address space. Okay, divided by the size, the page size, right? 8 bytes. Okay, this will be the number of bits. Number of bits. This will be a number of pages. Then after that, you have to go to how many bits. Yeah, let's do this yourself. And secondly, the second one will be the size of memory. So memory size over the page size. Yeah, let's have to do it. Yeah, and then you find out how many bits. Then you have settled this question. Yeah. Let's do this. Within 2 minutes, I believe you all can do it. Anyone would like to do? Chong Yi, do you want to do? Not then maybe Heng Dong. Heng Dong okay or not? Can do or not? Anyone also can do. So don't be shy. How about Yan Chang? Yan Chang, you can do or not? For this question. Yan Chang, yeah, who's that? Heng Dong, yeah, thank you, Heng Dong, for doing this. Han Xiang, sorry. Han Xiang. Yeah, which is Han Xiang. Okay, very good, Han Xiang. 8-bit, okay, very good. Yes, you can use text box, easier for you to type. Okay, very good. Correct. So we have Han Xiang doing this. Okay, so very good. So let's give a big round of applause to Han Xiang. Yeah, you have done this correctly. So 5 marks, 5 marks. Yeah, not very difficult. But for the 20, this one is 512. 2048512. Yeah, correct. Very good. Okay, now we do the last question. Last question is slightly difficult. Let's see what how's the question looks like. I have to think a little bit more. Of course, the final question might not be the same, but the concept will be there. So, yeah. So now, the question is like this: a computer has a cache that has a main memory and also has what's that? We have a cache. So we draw a cache over here. Yeah. If a processor needs some data, it will go to cache to take it. Then we have a main memory. Main memory. Eventually, you go to, if the main memory is not enough, you go to the virtual memory, right? Virtual memory. So these are the 3 memories you have. This one is very fast. Usually, it will be within the chips. or outside of processor, maybe not far away. And then the main memory will be far further. And then virtual memory is actually in hard disk or your SSD. So now we have these three things. So the processor will first refer to this. If not, then it will come to this. And then it will come to virtual memory. So if a reference word is in the cache, so you need 30 nanosecond, very fast to access the cache. Then if it is in memory, but it's not the cache, so you 60 nanosecond is needed to load it into the cache before a reference started again. So only you can start here. Okay. So if it's not in the main memory, so you need 12 millisecond to fetch the word from the disk, to the main memory. Then you need another 60 nanosecond to copy it to the cache. Then you take another 30 nanosecond. So the cache hit ratio is 0.9. So 0.9 of the times, this one will be able to, the hit ratio is this one, hit ratio will be equals to 0.9. So 0.1 will come to here. And then from here, we have the 0.60% hit here. So hit ratio is equals to 60%. Now determine the average access time. So how do you do the average access time? So average access time will be equals to 90% multiply 30 nanosecond, right? This will be the first case. If not, we have to go to the 0.1%. But 0.1% also 10% here. Oh, sorry, 10% here also. 40% will come to here. So you have to multiply 0.6. Then you get the 60 nanosecond. But don't forget, if you copy here, you have to get another 30 nanosecond to get from a cache as well. Okay, and then plus 0.1 multiply 0.4, right? It's 4%. Multiply 12000 plus 60 plus 30. Nano. Okay, nano. All this nano. So let's have to calculate what is the average access time in 5 minutes. Yeah, try to understand this and then try to calculate. Yeah, in 5 minutes. Who can do this? Han Xiang already done once. She already done. The other also can try. Yeah. For example, Heng Dong, Ka-Shing, Maylin, Yan Chang, EC. So this will be the question 1 and 4. Okay, may I know who did this? Yeah, I see an answer. Oh, yes. Suddenly the answer is here. So, may I know who did this answer? Let me see the answer. And my place. 516. Yeah. Can you check again? 516. Answer is. Okay, 516. GA. Okay, correct. Answer is 516. Yeah. Okay, very good. I think should be 516, right? Or maybe you can calculate again. So very good. Let's get a big round of applause to your friend. Very good. Yeah. So maybe you all calculate again, see whether my answer is correct. 516. Okay, very good. Yeah. Very good. To Yan Chang also. Yeah. So Yan Chang, right, should be. Yeah. Okay, thank you. So today we will only do until this question. Anything you want to ask me before we end our class today? Anything you want to ask? You can actually do many of the other papers, question paper as well. I have downloaded many of them. Basically, the question won't be the same now, but the standards will be there. So don't expect everything same. But the standards will be there. Yeah. So you just try out everything. The concepts. Do one by one then until you understand everything. We have a lot of papers like September. Perhaps when we finish our presentation, we'll do more. Yeah, do more of this. Yeah. So this is how we do. So any question you want to ask me before I let you to do your own thing? Not you. Okay, very good. That's here today. Did a lot of questions. And also Yan Chang. And so who else? Yeah, let me see. Already Han Xiang also. We've done some. So thank you very much. So if you have no question, then you may allow to leave. I understand you also have some assignments to do, right? According to your friend. So all the best to you in your study and stay safe. Yeah. And then start to study your revision already. I believe for our class, nobody need to make good. Yeah, hopefully. Yeah. So please prepare well your final exam. Yeah. Any question you want to ask me? If not, then you may leave. Thank you very much. Okay, see you. And I will upload this video to the classroom. Thank you.